All right, we're gonna hit day 6 right now, real quick. Hopefully, we can get it. Day 6, trash computer. Trash compactor. After helping the elves in the kitchen, you were taking a break and helping them reenact the movie scene when they're over enthusiastically jumped into the garbage chute. A brief fall later, and you find yourself in a garbage smasher. Unfortunately, the doors been magnetically sealed. As you try to find a way out, you are approached by a family of, I don't know how to pronounce that. They're pretty sure they can get the door open, but it will take some time. While you wait, they're curious if you can help find the youngest with her math homework. Yo, how do you say this?
Cephalopod.
Cephalopod. Interesting. Cephalopod. Okay. All right. The math worksheet, your puzzle consists of a list of problems. Each problem has a group of numbers that need to be added or multiplied. However, the problems are arranged a little strangely. They seem to be presented next to each other in a very long horizontal list. For example, each problem's numbers are arranged vertically. At the bottom of the problem is a symbol for the operation that needs to be performed. Problems are separated by a full column of only spaces. The left right alignment of numbers within each problem can be ignored. Okay. So 123 times 45 times 6. Okay. What is it? So it's like multiply these, add these, and then what? You just take the grand total? Okay. Bro, I think this is pretty easy. You just need to turn it into a grid and then just read the grid from like top to bottom for a column and then just like figure out the operation and then perform that operation on every single element in that column. That's pretty much all we have to do there. Yeah, I would do a PhD if I didn't care about money. Honestly, I just like to study. I might go to school now that I have this YouTube stuff. If I go back to my masters, like I'll just like make videos of me going through my masters and just make money on the side for that or something. Like that's also one thing about doing this. So literally all you need to do is just like turn this into like a matrix, then grab each column and then grab the operation, then just add them up. You can get a sponsored PhD. Are all the columns always going to be the same? At the bottom of the. Like, will some columns be longer than the other? Woo, what? Okay, to check. So I think we just need to split by spaces. We just need to take each line split by and split it by places and then to build the matrix, then we just go column by column and just figure out the operation. Kind of easy. I would do a PhD. Sorry, do 5. All right. Dude, that'd be crazy, man. Yo, these are a little too easy. I don't know if I'm really learning that much when it's this easy. You should do questions that are gonna. Maybe in 2026 I might do code forces. I'm gonna start doing code forces. Yeah, it's not this is not hard at all. Unfortunately. Honestly, like the day 3 kind of tripped me up a bit. Oh no no no. We need to just do split. Split by space. There you go. There you go. Now we just do an int here. Int element for line. Um, then let's create a function called compute column. We're gonna get a matrix. We're gonna get a column. Then we're gonna say result equals 0. Return result. So we're gonna say operation equals matrix at that column. We're gonna take length of matrix -1 to get to the bottom row and grab the column. While for row in range length of matrix -1 because we want to ignore the last one. If so, what are the different operations? Just multiplication and addition. If operation equals add, do one thing. What we'll do is result plus equal int, say matrix, row, and column. Else ooh, okay, wait. Because if it's multiplication, we'll do if If result equals none, then all you do is result equals something like this. So if the result is equal to none, we just add it, and then we keep, so that will help with the multiplication. For column in length in range length of matrix 0, what we're going to do is result of 0. We're going to do result plus equal. We're going to compute the column of the matrix at the specific column. We're going to print the result. Why isn't that highlighting properly? Man, this is a breeze. All right. Part 1 done. Part 1 done. That's a gold star. Continue to part 2. So we kind of just, all we did was like turn it into a matrix. Then we just would compute each column by taking the operation, which is at like the bottom of the column. And then we just like, depending on the operation, we do like adds or multiplication for that specific column. So that's just pretty simple. So let's move to part 2. Copy over this code. How do you pronounce this again?
Cephalopod.
Cephalopod. So the big cephalopods come back to check on how things are going. When they see that your grand total doesn't match the one expected by the worksheet, they realize they forgot to explain how to read cephalopod math. Cephalopod math is written from right to left in columns. Each number is given in its own column, with the most significant digit at the top and the least significant digit at the bottom. Each number is given in its own column with the most significant digit at the top and the least significant digit at the bottom, okay? Reading the problems from right to left, one column at a time, the problems are now quite different. We have 4. What? Where's 4 plus... The rightmost problem is 4 plus 431 plus 623. Wait, how does this work? Reading the problem from right to left, one column at a time. Okay. With the most significant digit at the top and the least significant digit at the bottom. Okay, 434. Is written from right. Okay, hold up. Do we two work on the same team? Nah. From right to left in columns. Each number is given in its own column, with the most significant digit at the top and the least significant digit. So, what is doing? Pluses? multiplication. Okay, I see. Oh, so it's aligned differently. It's aligned different. So it's like 4, 6, 3.
You have to get more coffee later?
I'm down. 4, 1, 3.
I need another ghost.
What is this?
I might start doing this tomorrow.
It's fun, huh?
Yeah. I need to
How does this even work? Wait, let me just read it. To the left. In columns. Each number is given in its own column. Okay? This number is given in its own column. With the most significant digit at the top and the least. So are we reading it from top to bottom? Okay, I see. Oh, okay. This is 4, 4, 3, 1. Okay, I see. What the? Okay, so it's kind of aligned. 4, 4, 3, 1, 6, 2, 3. So we need to maintain the white spaces. I don't think so. 175, 581, 32. Okay. So this is just like we're just working a little bit more like you just need to be able to work with the matrices a bit different. So we still want to split them, but we want to maintain. So I think all we need to do is grab this number 4 or like grab this number 4, grab this number 431 and grab this number, like add them to some result. And then like if you find the column that actually ends with this with an operation, then you just perform that operation of all the results that you built up. So we'll just move from right to left. You can even move left to right. Left to right. To multiply these. And then when you get to like it's blank. Oh no, we should probably move from right to left so we know that like we can skip. So what we'll do is we'll move from left to right. We'll start at right and then we'll like add it to like some number, right? And then once we find the operation, we'll just like perform that operation of everything in that number. Or like yeah, like everything inside of that array. And then we'll clear that array. If we just see, we'll clear that array and then we'll skip over one. And then we'll just keep doing that for each row. So now the code might just be a little bit tricky for this. So what we're going to do is we're going to look through the elements and we're going to split by a new line for sure. But then we could compute the column. We can remove that for now. But for every element, we don't have to do the split for every for element line, we just do this. Do they give us the same input? Okay, they just give us the same input, so we'll do test. These aren't hard, these are just straight coding. For line and matrix print. Yeah, now we just need to like go column by column. So for line in so we'll just start at -1 and then we'll go to -1. So we're gonna move from right to left now. And then we're gonna do compute a column. It's a Squid, it's a DP solution? Or it's a greedy solution. The way I did it was more of a greedy solution. So if the operation, if there's an operation, what we're gonna do is we're gonna return back the operation and like the number. So what we're gonna do is num equals number is equal to this. So what we're gonna do is we're gonna pull out the operation, and for row in range, what we're gonna do is num dot append matrix at the row and column. But then that will give us like in the wrong oh no, that will give us in the right order. We just need to join it. See how this looks. So Caesar, what's up? 4 4 3 1 6 2 3. Okay, then we just need to do current nums equals. So what we're gonna do is we're actually just gonna convert this to an int actually. What? Okay. Wait, what did it complain about? Join dot strip. Okay. As string. So we're gonna take the number and convert it as string. If as string is equal, if it doesn't even represent the number, then we just return none. All right, so we pretty much operation and the number. If operation equals none, these are what we're gonna do is this is when we clear it out. If the operation is none, we're gonna continue, but we're gonna like clear out our current numbers. Back to this, right? Because we want to add 4. When we get back, if operation actually exists, what was it do? If operation actually exists, if operation, then what we're gonna do is we're gonna figure out result equals like I wonder if there's a fast way to just multiply all elements inside of an array. But I'll probably just do this randomly. But if operation exists, we're gonna do one thing. Else, what we're gonna do is current nums dot append the number, right? If the operation equals plus, what we're gonna do is resolve 0 for limit in current nums. What we're gonna do is temp result plus equals the element, and after we're gonna do result plus equals the temp result. That's if the operation is equal to is for adding. If it's a multiplication, what we're gonna do is we're gonna take the temp result equals none. If temp result equals none, what we're gonna do is temp result equals the element. Else, we're gonna multiply, right? But at each point, what we're gonna do is we're always gonna add the current nums. Like this. Is it running? So we're gonna debug this in a sec. Result. We got the right result. Nice. Now let's run this on actual. Yeah, we're locked in if we just coded that whole thing up with no bugs. Woo! Day 6. Complete. Now I gotta post that one up. Yeah, we literally finished the first 6 days. Maybe they're gonna ramp it up and make it harder, but we'll see about that. Yo, Alex, how's the weather? It looks crazy out there. Is the weather good?
No, it's got cold. Damn. Come on, San Francisco. The weather is never good here.
Yeah. Okay, what do we have here? Yeah, so that was pretty much day 6. I'm gonna push this up. Chat, did that all make sense? Let's go.
How many are you going for?
I'm done them now.
What are you gonna do now?
I don't know. We'll see. Yo, it was way harder last year. Last year I couldn't.
Maybe you just got much better.
Yeah, I definitely got better, but last year was a bit harder.
You never know, man.
But like it got harder in day 10, 11, 12 and stuff like that.
Be careful what you say, because the next problem you're not gonna be able to solve.
Yeah.
Be careful.
All right, let's do a little recap right now. So in part one, what were they asking in part one? Pretty much in part one, we just needed to compute this equation, which is for every column, apply the operation at the bottom to that column. So we need to multiply every element in the first column together, right? And then we need to add every element in the second column together. So depending on the operation at the bottom is the operation you perform between each element in that column. Then afterwards, you just sum up the result if you perform the operation on every single column. So we just built an operation to just compute a column. So we did some string manipulation to split it up into the proper columns. And then we would just compute the result from each column. So compute column would just take a matrix and the column, and then it will grab the operation at the very bottom and then perform that operation on all elements in that column and return us the result. And you can see we're just like updating a running count, and we just did that for every single column. That was part one. Part two, what they wanted to do is they wanted you to look at each. They wanted you to perform a different operation where it's a little bit trickier to figure out what exactly they're asking for. I mean, that's what happens with these questions sometimes. But essentially, what you needed to do is you needed to look at every single column, and every column represents a number. So this column represents 4. This column represents 431 because the least significant digit or the most significant digit is going to be like in the first row of that column. So this represents 431. This represents 623, right? So now this is a block, and we need to add up 4 plus 431 plus 623. So we need to add those up, and then we get like some result. Then we look at the next batch. We say the number here is 175 if we're going from top to bottom, 581. But you see, this is eventually going to be a multiplication. So, and then 32 if we're reading from top to bottom. And that's equals x here. And we just do that for every single like block. There's 4 blocks here that we need to capture, and we just sum those all up together. So the way I did it is I just moved from right to left, capturing each number. And if I don't see an operation, I don't do anything yet. I just add them to some array. So I'll pretty much create an array of 4, 3, and 623. And then when I get to the column where I see the operation, I have all the elements there. And then I just need to know, oh, if it's an addition, I just need to add up all of the elements that I captured before. And then that gives me y. And then when I get to this row, I would clear out that array. And then I would just start building up the array again. So I got 175. Then I'll see 581. There's no operation, so I'll build up that array. Then I'll see 32, so I'll build up that array. But now that one has a multiplication, so I just need to know I need to multiply all these elements in this array to produce y. Right? And then that's sort of just how I solved that question of day 6. That's a recap. Didn't really learn too much because it didn't really make us struggle like some of the other days, but yeah, cool. Thanks for watching day 6.